Hello, YouTube. This is Umozo3. In the previous lesson, we had a chance to talk about pass by value, right? This idea that in Java and other programming languages, sometimes information is passed into methods by making a copy of the values of those variables rather than actually bringing in the identity of the variable by referencing it. Like if your name was Tom, maybe the word Tom would be brought into the method, but you yourself as a person, maybe that's not a good analogy, but you yourself wouldn't be brought into the method. But anyway, what we're going to do is we're going to be reviewing pass by value in this method, and also be talking for the last time about these different types of iterators and data structures, right? For the last like 20 lessons, we've been talking a lot about comparing and contrasting different types of iterators and data structures that are similar, but they have differing levels of functionality, right? We talked about how an enumeration is not as powerful as an iterator, okay? But an iterator is not as powerful as a list iterator. So by the same token, an enumeration is nowhere near as powerful as a list iterator. But what we're going to be doing is comparing and contrasting some of that functionality in this video. But what I wanted to do is really just talk a little bit some more about the pass by value stuff that we brought up in the previous video, because we gave a pretty quick treatment to it. But we're not going to be running all of this main method, right? We already talked in lessons 70 and 71 about using this list iterator, and we had an example with that, so we're probably going to skip that for this video. But what we can do is come back down to where we had this line of code that says object apple equals new PBV. So this is an example of polymorphism, right, where we declare an object as an object, right, the root of the class hierarchy, but we instantiate it as a P by PBV, which is the name of the class that we're in now, right? I just made that acronym for pass by value because that's the subject of this lesson. But we say object apple equals new PBV, and then we're going to say PBV banana equals PBV apple. So literally, banana is going to be both declared and instantiated as a PBV, whereas apple was only instantiated as a PBV while still being declared as a general object. And we say system.out.println of before and then banana.value. So what we do is actually let's start, sorry, so let's start actually right here. So int t equals, right, we were talking about int t equals 5 pbv dot add 2 of t and system.out.println of t, right? So we declare an int variable, right? We knew how to do that since lesson 3. And then we initialize the int variable to 5. And then we say pbv.add2 of t. So if we look for a static method right here in this pbv class that accepts an int, we can scroll down and it's going to be this method right here, right? It's static and accepts an int, and it says add 2. And what it does is y plus equals 2. So it accepts the input and it attempts to add 2 to it, right? So it's like 5 plus 2 is 7. But then when we say system.out.println of t, we still get 5 on the console. And that's a little ironic. And the point, as we discussed in the last video, is that Java passes information in by value. So it makes a copy of the 5 without actually passing t's identity into the method. And so that's why the variable was not successfully updated when we made that call to that method. So we talked about 3 solutions that we have, and the first is to use an instance variable associated with the class that you're in. So what we do is we come up with a constructor for our PBV class, But what we're going to do is practice with polymorphism. So we could say object apple equals new PBV. So again, it's declared in the object class, but instantiated in the PBV class. So if we look for a constructor, default constructor in this PBV class, that would override the default constructor from the object class that it inherits, then you would just say this of 100. What does this do? Remember, if you call this within a constructor and you have these parentheses, then it's going to invoke one of the other constructors. So it's actually going to invoke the constructor above, but with the default value of 100. So it's equivalent to saying this dot value equals 100. So that's what happens by nature of calling object apple equals new PBV, is that apple dot value would be assigned to 100, right? But then we can polymorph it, we can convert it to an actual PBV object. And the reason we want to do that is so that we can call the add method, right? Because objects can't add things, only PBVs can add things. So that's why you need to say PBV banana equals PBV apple. And then you can say banana.add of 2, and we look for a void method within our class that accepts an int, and it says value equals this dot value plus y. And so if we pass in 2 and the instance variable was already 100, well, 100 plus 2 is 102. And so that's why it says after 102 on the console. So hopefully that's clear to you. And then we talked about a second approach for pass by value, and that's to actually return the new value rather than just using a void method that doesn't actually return anything, but you could actually return something, right? So int cucumber equals 672. So we're declaring and initializing an int variable on the same line, just a little bit shorter hand than doing int t equals 5, but you can do either one. And then system.out.println of before, and then integer.toString of cucumber. So remember, we were talking about implicit casting in like lesson 7, like way at the beginning, but we said that if you combine an int with a string, the int is actually going to be converted to a string automatically. So you don't have to write integer.toString of cucumber, but you could. And this is what's happening automatically, but this would be like an explicit cast, even though the implicit cast would have happened anyway. But then what you're going to do is you're going to say cucumber equals add of cucumber with 8. So we need to look for a static method in the PBV class called add that accepts 2 ints and returns an int. And so if you scroll down, that would be this method right here. So public static int add of int my number and int to add, and it's just going to return the sum of the two numbers. So if you say cucumber equals add of cucumber with 8, well, what's 672 plus 8? Will be 680, and that would be the new value of cucumber. And you can see that it was successfully updated. So that was the second solution that we talked about to the pass by value phenomenon. And then in the third approach, we actually used a Boolean variable instead, because we said that this kind of stuff works not only for ints and doubles, but also for Booleans and also for the character data type. So on your own, you could use the practice from this video, you could use the explanations and the content to try coming up with this own phenomenon on your own, but using the character data type rather than the Boolean data type or the int data type that you saw in this video. But what we're going to do is declare and initialize a Boolean variable called C, and we're going to assign it to true, but then we're going to say invert of C. So we need to look for a static method in the PBV class that accepts a Boolean. So if we scroll down, we have public static void invert of Boolean A, and we try to invert the Boolean, so we're just going to say A equals not A. So then if we say system.out.println of C, for some reason we're still getting true on the console, so it doesn't look like the true variable was successfully updated to false. And so that's the phenomenon of pass by value. But we said the third solution that you have to that is to come up with a one-dimensional array, and then you can just increment, for example, the first element in that array, right? It doesn't have to be the first one. You could keep up with an array of 26 elements, right? And then if you wanted to update the 18th one, then it would successfully be updated. But usually if we're trying to come up with approaches to pass by value, you sometimes are only working with one value. So you only really need an array with one element in it. But the point is that you could come up with a one-dimensional array with that one Boolean element in it, that one true, right? Because it wasn't successfully updated, so it's still true. But you say pbv.invert of video game. So now you need to look for a static method in this PBV class called invert. It's still a static method, but this time it's not going to accept one Boolean, it's going to accept one Boolean array. So it would be public static void invert of Boolean A, but it would be like the array A, a Boolean array. And you say A of 0 is not A of 0. So flip the true to a false, flip the false to a true. So then the next thing that's printed on the console, if you say system.out.println of print element of video game, so we need to look for one more static method in our class called print element, which seems to return something, right? It can't be a void method if we're printing the result of it, but we're going to say print element of video game, right? So if you go public static Boolean print element of Boolean array A, and it's just going to return the Boolean value associated at the first element, so return A of 0. And you can see that we successfully get false as the next thing printed on the console, because when we use the one-dimensional array to do it, it turns out that the true was successfully updated to false. As opposed to when we just tried inverting that one Boolean. But if you invert the element within the Boolean array, then it works better, is the point. And then the last thing we have here is system.out.println of arrays.toString of video game. So roughly about 10 lessons ago, we were talking about the collections class and the arrays class. And we said the collections and arrays classes in Java provide a lot of helpful static methods for working respectively with dynamic arrays and static arrays. And so here we have a static array, but the point is that the arrays class, right? If you were to go to import Java, so you'd have to go ahead and say something like arrays Java API, right? And so what you would do is you go ahead and look at this one, you'd have to look for the toString method. We're talking about the static toString method. So you call it on the arrays class and it accepts the Boolean array. So you'd be looking at this one, but it returns a string representation of the contents of the specified array, right? But it would have like trues and falses in it. But you'd be using this overloaded version of the static toString method from the arrays class. So you say system.out.println of arrays.toString of video game, and you would go ahead and get false and square brackets. So hopefully that's clear to you. And those are the three solutions that you have to pass by value. So instead of just using that sort of basic static method, which didn't seem like it was doing its job, you can either use an instance variable attached to your class, right? You would go ahead and instantiate your instance variable. You'd assign it an initial value in your constructor, and then you'd have a separate instance method to add something to it or to change it in a particular way, right? So we had our PBV constructor. We assigned an initial value to the value variable, right? But then we also had this add instance method, which changed it. So that's the first solution. And the second solution is to simply return a result rather than using a void method. So that was this static add method that accepts two inputs, right? That was how 672 got updated to 680 a few minutes ago. And then the third approach we were just talking about is to use a one-dimensional array instead of a simple element. So hopefully that's clear to you, and that gives you a decent review of the pass by value phenomenon. But you can go back to the previous lesson if that's still unclear to you. What I wanted to do in this video is just do a little bit more review. We have about 9 more minutes. I just want to review concurrent hash maps and sort of dictionaries one more time, right? We were talking about how there's a lot of different types of data structures in Java, right? Index lists, there are two types of index lists, either array list or vector. Array list gets an iterator and a list iterator. Vector gets an iterator, a list iterator, and an enumeration. And then there's only one type of linked list, right? With linked lists, we're not talking about index positions, really. We're talking about nodes pointing to the next node. So that would be a linked list, right? And that gets an iterator and a list iterator. And then we talked about stacks, which is a last in, first out data structure. So you really want to understand the push and the pop and the peek methods, right? But that would be for a stack, last in, first out. Think about a stack of dinner plates, but that gets an iterator, a list iterator, and enumeration. And then you also have a queue and a concurrent linked queue. But we said queue is only an interface which implements a linked list. So you either say queue of type X, my queue equals new linked list of type X, or you say concurrent linked queue of type X, my queue equals new concurrent linked queue of type X. But in either scenario, you need to import the proper classes depending on which approach you decide to take. But that only gets an iterator. And then with sets, remember two types of sets, so hash set and linked hash set. We're talking about an unordered collection of unique elements, where if you add a duplicate or remove an element that's not there, it doesn't throw an exception, it just doesn't have any effect, it just doesn't do anything. So if you add the element 662 times, you're going to have 1, 6 in your set, not more than one. And then, so the sets, the hash sets and the linked hash sets, right? So two different types of sets, and they get an iterator. And then you have 4 types of dictionaries, right? So the hash map discussed in lesson 55, the hash table discussed in lesson 64, the linked hash map discussed in lesson 68, and the concurrent hash map discussed in lesson 69 and reviewed in lesson 70. But what we're going to do is we say concurrent hash map of type string and integer, D1 equals new concurrent hash map of type string and integer. And like up here, remember we said that we have to import the packages or the classes that we want to use. So anything from the java.util package, you'd either have to import those particular classes or import the entire package. So I do that not only for java.util, but also java.util.concurrent, because concurrent hash map belongs to the java.util.concurrent package, which is distinct from the java.util package. So hopefully that's clear to you. But string, and we're going to have a one-dimensional static array of string objects. Apple, walnut, hip, sunny, incredible, it, stop, and toast. So you get about 8 words there. For each string k in keys, d1.put of k with k.length. So remember, the put method for all these dictionaries accepts 2 arguments. The first is a key and the second is a value, and then it creates that key value association, kind of like adding an element to an array list, but this time we have to add not only an element, but also like a value, right? A key and a value at the same time. And so we're just going to basically add the key value pairs, but for each of these keys, it's going to be the value, the length that's going to be the value associated with it, right? So for example, apple and sunny, well, those will be 2 different keys to have the same value, because both of those words have a length of 5. And we said the keys in dictionary have to be unique, but the values in a dictionary don't have to be unique. So hopefully that's clear to you. And linked hash map of type string integer D2 equals new linked hash map of type string and integer, right? Linked hash map, as we talked about in lesson 68, similar to a concurrent hash map, it just doesn't get an enumeration. D2.put of apple with 422. So you can see this apple key is also coming into this D2 dictionary, but the value associated with apple in the D2 dictionary is different from the value associated with apple in the D1 dictionary, right? It's not going to be 5, it would be 422. But then what we're going to do is say d2.putAll of d1. So this is just another example of how you can mix and match dictionaries. If you call the putAll method, it's a void method. You call it on one dictionary, it accepts another dictionary, and you can mix and match types. You can add the key value pairs from a linked hash map into a hash table. You can add the key value pairs from a regular hash map into a concurrent hash map. You say d2.putAll of d1, and then iterator of type string key parse equals d2.keyset.iterator. So it's going to produce an iterator on the keys of the D2 dictionary. And so we need to see what value is going to be associated with Apple. Is it going to be 422 like it was originally, or is it going to be replaced with 5 by virtue of calling this putAll of D1 method? So you say int v equals 0, and then we can review the do while functionality and also the system.out.printf. So I'll link to lesson 45 in the description when we talked about formatting strings, but this is a clean way to produce a string if you want to have something a little bit more interesting than just reading from left to right. So we can go ahead and run the main method for this class, and we can scroll up, right? And so what it does, we have a do while loop, and it says string my key equals key parse.next, and then we use this sort of %20s, right? So that's going to stick in 20 characters minus however many characters it takes to write out my key, right? So you'd have 15 empty spaces here because this would be a total of 20 characters, but it's like Apple takes up 5, right? And then the same thing, this would also be 20 characters up to this 5, right? Because it says %20s, so you have to feed in these string arguments. We're talking about this formatting thing, and we said it's not a problem to feed in too many arguments to the system.out.printf, but it would be a problem to not feed in enough. So you'd have to have at least 3 here because you see a s 3 times within the context of this formatted string. But the first one would print the key in the dictionary. The second one would print the value, right? d2.get of my key. That will give you the value associated with that particular key in the dictionary. So it's just telling us the length of each of the words, because that was the virtue of this for loop right here. So we said we just want the value to be defined by the length of the key, right? And it looks like the 422 for Apple was overridden, right? It was replaced by 5 because we said d2.putAll of d1, and that's how the putAll method works. And then the third string would just be for a new line character. So remember talking about the escape sequence as the \n. So it sort of prints these 3 strings, right? One for the key, one for the value, and one for the new line. And you're just going to keep iterating. So you keep incrementing v, and then eventually v is going to be as big as the size of the dictionary, and you're going to want to break out, right? Because there's not going to be another key to parse, right? So if you say system.out.println of key parse.has next, well, now this will be false by the time you exit the loop. And if you say system.out.println of v equals d2.size, well, that would be true because now both of them should be 8, okay? Because that do while loop ran exactly 8 times. And then you can also review instance of real quick, right? So you could say system.out.println of key parse instance of iterator. So is key parse an instance of iterator? True. But is it an instance of list iterator? No, it's just a traditional iterator. Is it an instance of enumeration? No, it's absolutely not an enumeration. Okay. The iterator is not a subclass of enumeration, right? Because typically we think about subclasses as getting all the functionality from the superclass and then having more. But you have to understand the enumeration is not a parent or a child of iterator. These are two sort of totally separate things within the Java object-oriented hierarchy, but those will both return false for list iterator and enumeration. But if you say system.out.println of key parse instance of objects, that would be true. And you can practice with exceptions a little more. So exception egg equals new index out of bounds exception. So that would be declared as a regular exception, but instantiated as an index out of bounds exception. But then you can actually convert it. So index out of bounds exception E equals index out of bounds exception of egg, right? So E would be both declared and instantiated as an index out of bounds exception. And so if you ask if E is an instance of runtime exception, well, that would be true. If you ask if E is an instance of index out of bounds exception, that would be true. But if you say if E is E an instance of array index out of bounds exception, well, that would be false. That would be the false right here because that would be too specific. So if you say try system.out.println of pizza, remember the try block is going to run as much as it can until it hits an error. So pizza, and then it tries to just throw an exception. We literally try to manually throw the exception, but since we're in a try catch block, it's going to be caught. Okay, so it's going to be this catch block that catches the exception, because it wouldn't be an arithmetic exception, it wouldn't be a string index out of bounds exception, but it would be the first specific exception that applies to that exception. So it wouldn't be the runtime exception, because it wouldn't be this more general one, because we already caught a more specific one. So it would run this line of code, and then we would run the finite block runs regardless. Hopefully that's a good quick review of formatted strings and pass by value and exception handling from UML 3. Thanks for watching, and please subscribe.